All right, so just to make sure that you all haven't wandered in the wrong session, for the next 50 minutes or so, I'm going to try to convince you that using a policy decision point inside of an LDAP server is a good idea. But we're going to focus on the idea rather than a product. So right now I'm training for a 200-mile bicycle ride on gravel, and so that's keeping me pretty busy. That's happening in June. And so when I'm not doing that, I try to get some work done at Simus, and I'm a member of the PMC of Apache Directory, and I moonlight with OpenLDAP. So our agenda is we're going to examine this idea and rationale behind this policy decision point inside of LDAP business. And in so doing, we're going to take a look at the specifications and requirements that surround it. And we're going to have a look at an implementation called the OpenLDAP Accelerator. And we're going to talk a wee bit about standardization. And we're going to have a couple demos along the way. So the reason why I'm standing here in front of you today is back in 2012, we hit a wall with policy enforcement. And we were trying to build out some policy enforcement points that work natively to work with the Fortress system that is a Java-based. And what we found out was to build that, which is a policy enforcement point, so what we wanted is we had to build one of those, which is a policy decision point. And that didn't sit well with us because that's a lot of work. So my colleague Ted Chang at the time said, hey, why don't we move the policy decision point inside of OpenLDAP? I was like, are you crazy? He's like, yeah, because in that way, we only have to build one. So we have this policy decision point that, that any platform can use. And plus, we get to utilize the natural strengths of the LDAP protocol. I said, I took another bite of my pasta Milano because we were at Olive Garden. I said, that's a good idea, Ted. And so then we brought it back to our guys at Simus, and we said, Ted thinks we ought to put a policy decision point inside OpenLDAP. And I don't know if you guys know about Simus, but we're the guys who do OpenLDAP, and our engineers are pretty crusty. And they looked at us about like John Cleese is looking right there. Like, you got to be kidding me. And that's about how you guys are looking at me right now. So obviously I haven't convinced you. So I'm going to try to convince you with the rationale. But before I can do that, let's talk a little bit about how we construct access control systems. So an access control system is composed as three most basic elements of three components. You have a policy enforcement point, a policy decision point, and a database. And the policy enforcement point is used for doing security checks, right? And so it's the security system's gatekeeper. And it requires platform-specific bindings because obviously it's running on the platform, right? So if you need a policy enforcement point for C, then you got to write in C, so on and so forth. And it's best to reduce the impact of the host machine. So the less code you put down on the host, the better off you are. So we all know what a database is. But with respect to this conversation, a database is used, it's invoked by the policy decision point to store security stuff. And so it is the security system's long-term memory. And to be effective in this context, it has to be reliable, consistent, and above all, fast. So the policy decision point is invoked by the enforcement point. It's dependent on a database. And that makes it the security system's brain. So it's really the central element to this system. And it authenticates with passwords and keys, and it authorizes with permissions and attributes, and it better leave an audit trail. So we can take these three elements and we can compose them in various ways. And so for lack of a better set of nomenclature, I came up with this type 1, type 2, type 3 business, just so that we can describe the various ways to put these things together. So this is what Ted and I were doing that day, so that's a type 1. And that's where you have the policy enforcement point and the policy decision point sitting alongside each other on one tier, and you got the database in another. And so that means they're running in process and the database is out of process. And so the decisions happen synchronously inside the client. The decisions are, in essence, happening inside the client. And so that combines them into a single component. And most of your open source security frameworks are this type. And so, Tomcat JDBC, Realm, any kind of Tomcat thing like that, so type 1. Apache Fortress, which is my pet project, that's a type 1. Apache Shiro, Spring Security, they're all type 1s. So there are some advantages to it, and the first one is it's simple. That's simple for me, right? It's simple for me to build one, because all I need is a framework and a database, and off I go. And so that means there's going to be a lot of them out there, because they're easy to build. They're widely available. And they work well for certain things. So if you don't have a gazillion nodes to deploy it to, it's just fine. If you don't need it for many platforms, it's just fine. And it's good because you got lots of options, because you can, SQL, LDAP, whatever, there's lots of ways to store the data. Disadvantages is that you've got more stuff on the client. You've got to put more code on the client. You've got more load on the client. You've got more network I/O, more memory consumed, more, everything. It just makes everything harder to do. And then the other thing is that it's harder to keep repeating that. So to build that policy enforcement point, that policy decision point again and again and again, so like I built one for Java, and then you got to do it again for C, and you got to do it again for Python, and it's just a lot of work. So then we have a type 2, and that's where everything sits on a separate tier. And so the enforcement point, the database, and the decision point are all running out of process from one another. And that is more complicated to do than a type 1. And these are typically obtained as commercial off-the-shelf components because they're hard to build. And so all the biggies have them, and they'll be happy to charge you lots of money to have one in your data center. And there are a few of them that are available in open source. So CAS, Shibboleth, OpenAM, they're type 2s. And they have some advantages, for sure. And that is that there's less stuff on the client. So you got less traffic, less CPU, less memory, less code, because that policy enforcement point's just a little bit of code. It's just a pass-through. And so there's going to be because you only have to build a little bit of code for that enforcement point, you're going to be able to support lots of platforms like these things, like the big ones do. But you got some disadvantages, too, because we've added another process that we got to care and feed for. And so that creates a burden for the system administration team to take care of that. And even worse, we've just increased our latency by a factor of 2 because we've got another hop. So instead of just going 1 hop, I got to do 2 hops. And then, and this is probably arguable, but most of those decision points use a relatively heavyweight protocol called HTTP, so that's going to hurt you on performance too. So that brings us to a type 3. So here we have the policy enforcement point on one tier, and the policy decision point are together on another tier. So the decision point and the database are running in process, and the enforcement point's out of process. So as of when Ted and I were working on this, we didn't know of any access management system that's a type 3. I've since heard that OpenDJ has a type 3, but I'm not sure if it does or not. So our pros and cons look a little different. So in terms of the pros, we get all of the type 2 pros. And so this is speculative at this point, right? Because we didn't have one. So I'm still trying to convince my management team that we want to go forward. So we were speculating that it had all of type 2's advantages. And I think it's logical to say, well, you're going to get an embedded database speed gain because the database is sitting right there. So it doesn't have to do a network hop. So we're going to gain speed there. And you're going to have a reliability gain because the decision point and the database are clumped together, and so that's going to be more reliable than if it has to go over the wire. But you got some disadvantages. Now that we've bound this database and the decision point together, now we've got fewer options for the database. So it's not like we can just use any SQL engine. You've got to have something that can run embedded with that. So we reduced our options there. And we still have poor throughput because we're still using HTTP. So that brings us to LDAP. And so I'm an old guy, and so and us old guys know what LDAP is. Right now, it's part of the plumbing in the data center, so you may not use it. But it stands for Lightweight Directory Access Protocol, and it is a vendor-neutral, industry-standard application protocol for accessing and maintaining distributed data over the internet. So what does that mean? It's a specialized database, okay? It's just a special database. And it is standards by a series of RFCs from the IETF, in particular RFC 4511. Okay, so what happens when we take LDAP and we put it in our type 3? What does that do for us? Why would we even want to do this? Well, number one, it's standards-based, so it's portable. So any client that I write for LDAP is going to work for any LDAP server, period. Very interoperable. Number two is now I've got a compact and efficient wire protocol, because LDAP uses what's called BER, Basic Encoding Rules, which is an ASN.1 notation, which is very fast, very efficient, very lean and mean, way faster than HTTP. Supports robust and replication, high availability right out of the box, so it's safe. It's got a rich data model, which is good. It's hierarchical. It's perfect for access management. And it's relatively easy to code that even a guy like me can do it. So there's only 6 operations in LDAP. Add, update, delete, search, bind, and compare. So I got this. I can do 6. SQL, too much, but I can do LDAP. Okay, so what happens when we take LDAP and we put it back into our matrix with pros and cons? What does that do for us? So with the advantage, and again, we're speculating, right? So the advantages are all of type 3s. So less code on the same thing. The policy enforcement point hasn't changed. It's running by itself on the client. So you got less stuff on the client. So you got all of the advantages you had before with the type 2, and then the type 3 without LDAP. Disadvantages, we're still bound to an embedded database, so we still have that. But we've crossed out poor throughput. So that's where we left it. And so after we made this proposal to the management team, they were kind of looking at us and they're like, yeah, that's a good idea. Let's do it. Yeah, let's do it. So then Ted looked at me and said, what's it? What is it going to be that we're going to do, right? What are the specifications? What are the requirements? What are we going to build? So these system requirements are not unusual to this build out. So any access management system is going to have requirements that are going to look something like this. Of course, we wanted policy enforcement APIs that worked across multiple platforms. That's what got us there to begin with. We wanted an authentication mechanism that could get out of the way of the modern protocols. So, LDAP binds are fine, but you can't rely on that. So there's lots of ways to authenticate. So we wanted to be able to work within the OAuths and the OpenIDs and the SAMLs of the world, because we're not going to reinvent that. Speaking of reinventing, authorization has to be fine-grained standards-based. We're not going to invent an authorization way to do it. There's too much of that going on in this world today, right? So we're going to do it in a standard way. Has to. Otherwise, we're part of the problem. We're part of the noise. We're going to leave an audit trail, and it's going to be queryable. We didn't have to worry about administration because this is using the Apache Fortress model, so we could build on top of that. So we didn't have to worry about that. And then we had service-based SLAs, right? This is going to be running SIMUSes in some of the bigger data centers of the world. And so it had to be fast. It had to be reliable. We couldn't sacrifice on any of that. So we had some other things, miscellaneous requirements. If you're going to do passwords, do them right. Has to be multi-tenant because we're in a cloud-based world. And a couple other things. So, yeah, audit has to do all those things. Temporal constraints, not important for this conversation. Persistent or transient sessions is a fairly interesting, any security system is going to have a session. And that session's either going to be handled by the client, you're going to pass it back to the client, make them take care of it, or you're going to persist it in the database. And there's pros and cons to each. We went with the persistent because we wanted that client to be as skinny as possible. And we like the idea of having this more control centrally, because security is all about controlling stuff. So the more control we have, the better off we are. Non-functionals, that's true of any security system. Latency and performance, so we were shooting for the moon. So we wanted less than a millisecond round trip time, greater than 100,000 transactions a second. That was our target. Functional specs, what are those? We're agile, right? We'll figure it out. Let's just do it. No, we're not going to just do it. So we use role-based access control, ANSI Insights 359 for the authorization. And then if you got to use a password, do it right. IETF password policy drafts, the best thing we got. So we use that. What's role-based access control? Everybody says they have it. We're using roles. We're role-based access control, right? I sat in an audience like this a couple years ago at Java 1 and listened to an expert tell me, role-based access control, it's an anti-pattern. Don't do it. Really? Why'd you say it was anti-pattern? Well, if you're doing is user and role in your code, then you've locked yourself into that role, and you really ought to use a permission. Dude, do you even know what role-based access control is? It's got permissions, right? So anyway, so this is role-based, ANSI Insights 359 specifies security in 4 broad areas. And RBAC 0 is the base. So that's users, roles, permissions, and above all, sessions. Sessions is context for which roles are activated. Just because that role's been assigned doesn't mean it's going to be considered in that access control decision. Then you got hierarchical roles, RBAC 1, static separation duties, RBAC 2, dynamic separation duties, RBAC 3. That's RBAC, okay? All right, so functional specs. So ANSI Insights 359 takes it to a very explicit description. And so in addition to sort of the human readable, so this is a page out of the Insights document, by the way. So in addition to this, you have this funny looking text here on the bottom. Well, what is that? That's Z notation. So that's a formal way of representing functionality in a system without being tied to an implementation. And if you can read it, it tells you exactly what that function's supposed to do. There's no ambiguity, no confusion, which is a beautiful thing for a programmer, right? So there's no guesswork. We just had to figure out how to do it. And there's 3 interfaces for RBAC. There's admin, so that's how you put the data in. There's review, that's how you interrogate it. And then this is the one we focused on, the policy enforcement. So that's what we're going to put inside the LDAP server, is that interface. The other 2, Fortress does. We didn't have to rebuild that. So here's a kind of a peek at the client side of the interface. And that's kind of an eye chart, but there's not anything special there. That's what you think of when you think of access control. So that's how, those are the APIs interface, to create the session. That's kind of like authentication with role activation. And then you've got like check access, that's a permission check. And then you can add and drop a role in the middle of a session to add and remove power in the session. And there's reasons for doing that. If you stick around for my next talk, I'll explain it. But it's all in keeping with the principle of least privilege. Only give the user the power they need to do their job at any given point in time and no more. Again, it's about control, right? We want to control it. We want to eliminate conflict of interest. We want to control our environment. We want to protect the user from himself. So the main API here is check access. That's how you check a permission. So given a permission, can you do it, yes or no? So what's a permission? It's a mapping between an object and an operation, plus it can have an identity. So you can say customer record, read, 4, 5, 6, 7, 8, 9, 10. Can I do it, yes or no? So this is all pretty abstract. And so I want to kind of tie it into your mind a little bit better and have a real quick demo. So we're going to go over this use case. And this is a very simple sort of a watered-down eBay thing, so kind of an online auction. So this is our policy, and we've got a base user. So this is a hierarchical role right here. So we've got 3 roles. We got this generic user, we got a buyer, and we got a seller. The buyer and the seller inherit from the generic user. So any user in the system can create an account or search for items, but only the buyer can place a bid and purchase items, and only the seller can create an auction or ship items. And then I'm going to have a constraint here to say one and only one of these roles may be active in the session at a time, because there's some kind of conflict of interest going on where we don't want any particular user to have, and this is contrived, but it's just giving you an example of what we can do. So I've got this app running in a cloud environment. So I'm going to go ahead and hit it real quick. Well, wait a minute. I'm getting ahead of myself. This demo is online. It's in my GitHub account. All the instructions to run it and use it. If you want to try it out, you can pull it down on that link there. And these slides are published. So if you want to go back to the ApacheCon site, you can get to them. And so here is our policy and the app. It's a really simple app, 2 pages. Each page has some buttons, and those buttons are controlled by permissions. And so we got a buyer's page and a seller's page, and then we got 3 users. So one user is a buyer, one user is a seller, and one user is both. But that user that's both can't do both things at one time. Okay, does that make sense? Pretty simple, right? So that's what we're going to demo. Kind of just a really simple use case to kind of give you a taste of what we can do here. Okay. Can y'all see that? So I'm going to log in first as a buyer. And you can see when this user logs on. Can you guys see that? Okay. So, again, every user inherits from the user role. So they get those the user functions. And then this user's a buyer, so the buyer link shows up, and then they can do buyer things, right? So, and this is just, like I said, a contrived example. And then I've got to switch to seller, which if I click this button, it deactivates the buyer role and activates the seller role. Well, this user hasn't been assigned to the seller role, so they get an error like they should. So then we got another user. Who's a seller. And again, the user's menu's there, the seller link's there. They click on it, same thing. They can do the seller thing. If they switch to buyer, they can't. And then the third user is both. This user is going to log in, and the system's going to make them a buyer at first, so they can do buyer things, and they can do click on buyer buttons. But this user can switch to a seller, right? So they click on switch to seller, and they're allowed to, and then you got the seller page. So that's in an active session, we are deactivating one role and activating another, but we're preventing them both from being done at the same time. So this is a trivial example, but there's lots more sort of comprehensive use cases if you'd care to examine it. Password policies have been around a long time. There is no real standard for password policy. It's never been ratified. But there is a draft, and that is the default standard. That's what we all use. And so, again, it's going to tell you how to do it right. And so if you're going to handle a password, handle it right. If you got to do it right. And that's the nice thing about a spec is when you're just starting out, you follow a spec, and it's going to guide you. And you're going to be satisfying requirements you didn't know you had. And it's better to be surprised that way than the other way. Say, well, can you do Grace? What's that? So if you implement a spec, then you're covered. All right, so that's what we did. Well, I told Ted, yeah, go do that. And he's like, okay. So he went off and did it. And he created this thing called the OpenLDAP Accelerator. And so here's what we came out with. It's pretty simple. You got OpenLDAP up here, which is our special database, if you remember. And so it is now a type 3 policy decision point. So it has, inside of that, which has a database, there's also the accelerator, which is the policy decision point. And then we have various ways to access it. So the Fortress core APIs themselves can be used to interact with it, or any platform that can do LDAP v3 extended calls can do it. So Python, PHP, whatever. If you've got an LDAP toolkit, you can interact with this thing. So it's real easy to build policy enforcement points now. So the components, we got a server and client side. Server is what I just said. It's an OpenLDAP overlay. It's called the SLAPO RBAC overlay. And it's a type 3 policy decision point, includes a database. And then the client side, we got bindings for various platforms. That's the policy enforcement point. All right, so what is OpenLDAP again? I'm talking about like everybody knows. It is an implementation of LDAP v3. And it is arguably the most widely used directory server on the planet. Maybe second to Active Directory, I'm not sure. Certainly within Linux environments, it's the most commonly used. And in fact, it comes on just about every Linux distribution made. OpenLDAP's just there. What's an overlay? I could read you that, but I'm not going to. Just think of it like turning OpenLDAP into a Swiss Army knife. OpenLDAP has lots of overlays. There's an overlay for password policies. There's an overlay for doing all sorts of things. We created one for this. So this is summary. Server side is it's an OpenLDAP overlay. It implements our back system manager interface, which are those APIs there for doing policy enforcement. And it uses LDAP v3 extended operations. Is this making sense? Do I need to throw frisbees? Okay, client-side bindings. There's 3 sets. One of them was written by my colleague and friend, Emmanuel Charnay, who's well known in Apache circles. And that's called the OpenLDAP Fortress Accelerator. That's in the OpenLDAP Git, and that's production ready. And that's what I'm going to demo here in a few minutes. Ted built a set of bindings for C that we haven't released yet. And then there's another set of bindings for Python that was built by a team at University of Hawaii. And we are in the process of liberating that for a team at OpenStack that works with OpenStack that wants to use it in a Python platform environment. So this is kind of just a summary slide. What are the features? It's ANSI Insights 359 compliant. It does IETF password policies, persistent sessions. It's multi-tenant. It enforces temporal constraints, which is time-based policies on usage, and it leaves a full audit trail. Okay, so the functional model is we created 7 new extended operations that are running inside the server that correspond with the APIs that we've been talking about. And then there's a number of operands that control the entity flows back and forth. Here's an example of create session. This is an ASN.1 notation. This is the extended protocol that goes on the wire. Basically, what you're going to do is you're going to give it a user ID, optionally a tenant ID. You don't have to give it a password. That's optional. If you're in a single sign-on environment, you can create a session without it. And then you can optionally give it 1 or more roles to scope it back to that principal least privilege. Just because you've been given all those roles, it doesn't mean they're going to all be considered. And and if you don't pass any roles, then the server is going to activate all that are eligible to be activated. So the server is going to give you back a session ID, basically. And then that session ID will then be passed in on subsequent requests. So here's check access. You give it an object, an operation. And if the object has an identity, you give it that, and it returns a Boolean. So pretty simple. And on check access, like I said, it'll return a Boolean. Logical data model, it's using the Fortress logical model. So we had to do that in C. So we had to create these data structures in C to run an OpenLDAP. And the physical data model is going to be the Fortress physical data model, which is all this stuff stored in a directory. So this is the policy, an example of the policy. And I don't know if you guys can read that. But just think of users, roles, passwords sitting down inside this tree. And the physical model is it's all based on performance, runtime. So the way we arranged this data was about to make it the minimum number of accesses to make this thing as fast as we possibly could. Again, we want microsecond latency, 100,000 plus throughput. So we made this thing as lean as we could. So here's an example of what I'm talking about. Here would be a physical user record in LDAP, and the roles are right there. And so the reason why we did that is when all you got to do is one read. When you create the session, bam, the roles are there. We don't have to search a tree and get this. So these are the kinds of things you can do in LDAP that make it go really, really fast. Standardization. Why do we want to do it? Why do we want to standardize? It can be nice to encourage usage and interoperability. So we create a set of client-side bindings that work for Java, and another one for C, another one for Python. Maybe somebody else built one for PHP. And so those client-side bindings could work with any server. So if we standardize this, again, LDAP standard, if we standardize this protocol, then any directory server, it wouldn't have to be OpenLDAP, could do this as well. And then they could all use the same set of policy enforcement bindings. And maybe we'll actually start doing authorization. That'd be good. We won't hear that excuse, it's too slow, it's too hard, we're not going to do authorization. We authenticated, we got a firewall, we're good. Okay, so what are we going to standardize? We're going to standardize the LDAP schema, that's the object model. We're going to standardize the LDAP v3 operations I showed you on that functional model for the wire protocol. All right. That'd be the target of standardization. Where would we do it? Oh, I'm sorry. Which servers? OpenLDAP already did it. Apache Directory should, and we probably will. OpenDJ could. 389 could. Active Directory could. Any of them could. Where? IETF. So right now, we're just kind of waiting. We're going to see what happens. We're not going to go to all this trouble unless the community seems interested. But it's just an idea right now. All right. I lived in Missouri for a year, and they had a saying, show me. Right? You say it's fast. You say it's good. Show me. Prove it. Prove it's fast. Talk is cheap. So I'm going to try to prove it to you. All right, so I'm going to do two tests. All right? The first one is going to be sort of the existing way that Apache Fortress works. So this is a type 1 policy decision point. So what that means is the policy decision point and the policy enforcement point are residing in the client. Okay? It's type 1. And then the server is just a database. Okay? And it's storing the audit there and the policy there. And then I've got a couple overlays active. It's got password policies, and it's doing this SLAPO access log is how we trigger the audits. And I'm not going to go into how that works, but just trust me. It's doing an audit. This is all running in the cloud. CenturyLink has been kind enough to let us use these machines. And so I'm going to fire up a test using JMeter that's going to fire up 35 threads on the client machine, and each thread's going to call check access 50,000 times. And we're going to see what happens. So what's going on with check access with the type 1 policy decision point with Apache Fortress? For each invocation to check access, it's actually going to hit the server twice. Okay? The first time it's going to do a search and pull back the permission and decide whether the user can do it or not. And then the second time, it's going to do this funny compare business to trigger an audit. So in order to do the full thing, to do the check access and to trigger the audit, it's going to require 2 round trips to the server. And so we're going to go ahead and see how it does. Okay, so this is a JMeter test. And this is running on the client machine. I'm going to fire it up. Can you guys see that? Yeah. So it's going to kick off 35 threads. And it's going to go just as fast as it can. So this is the client side right here, top. And you can see right there maybe that client's pretty busy. 80% CPU. He's cranking pretty good. The server side. Hold on. 20%. Server's not even really breaking a sweat. He's just acting like a database. Yeah, really haven't got his attention yet, but the client is working pretty hard. So as far as throughput, it takes a while for this thing to get warmed up, but right now that's about 5,000 a second. It says an average, so where are we at now? 6,500 a second. It says a 5 millisecond latency, which is pretty good. If I run this thing a while, it'll kind of work its way up to about 10,000 a second. It'll be about the peak load it can handle in that format with 35 threads, which is pretty good. 10,000 a second. It's not bad. So that's a type 1. So that's where the policy enforcement point and the policy decision point are sitting on one tier. So it's that client side, which is right here on top, is having to do more work. And the server is doing less work because he's only doing a database. And so yeah, we're running about right now 6,000 a second. I'm going to go ahead and stop this. It's good enough. Okay. So that's a type 1. So what about a type 3? So this is okay. So this is the accelerator now. So up in the server, up here, Now we have this slap OR back box, so that's the overlay. That's the policy decision point. And then that's the database for the policy, and then we've got a database for the sessions, and we've got a database for the audit. And then the client now, it's still Fortress Core, but he's going through a different path. And so, and he's just now a policy enforcement point. Okay, so I'm going to rerun the tests this way and see what happens. And so what's going on as far as a call trace behind the scenes? So the client invokes check access, and then there's now just going to be one round trip because we don't have to do that funny audit business anymore because we control the server. And so the audit happens automatically, which is good. And but we've got, now we've got to maintain the session on the server. So that server's got to do more work with that data. There's going to be more I/O because he's got to persist that session there in addition to the audit. So let's run it again in that configuration and see what kind of numbers we get. Okay, so it's the same test harness, still JMeter, but now I'm going to invoke a different set of APIs that's going to do what we just talked about. So I'm going to fire that up. And this time, this is actually 40 threads that goes on the client side because it's leaner. I can spin up some more threads. And so he just fired up 40 threads there. So let's look at the client, let him settle down a little bit. He's cranking, now he's starting to settle down. So with 10 more threads, he should run a little bit quieter. And we'll give it a second to settle down. On the server side, this is top, and you can see now we're starting to get the server's attention a little bit. He's running about 50% CPU now. You can see memory is really stable, so it's actually still pretty efficient on the server side. So the client is, it's running 50% CPU, 40 threads. What about performance? How are we looking? There's 17,000 a second. Average time of 2 millis. Minimum is now 0, which means, we can't measure microseconds with, it's really hard to measure when you get down to microseconds in terms of latency. If anybody's got a good way to do it, I'd love to hear it. Certainly JMeter can't do it. You can see he's kind of, he's now up around 18. With this configuration, the way I've got it, it can do about 20,000 a second with around 1 millisecond latency. So clearly better, right? Doing the same thing over twice as fast. You guys get the idea. I'm going to go ahead and kill this. All right. All right, so where does that leave us? So just to summarize, with the type 1 policy decision point, 35 threads, you didn't see it, and it's kind of hard to get consistent when you're in the cloud because you're not really on bare metal. So, but the high water marks about 10,000 a second with that test scenario, and about an average 2 milliseconds latency. And with the OpenLDAP Accelerators, the type 3 is with 40 threads, the high water mark's about 20,000 a second, average of 1 millisecond. So we thought that was pretty conclusive. Leaner on the client. You're distributing the load where it belongs on the server. You imagine a data center that has millions of nodes. You want it as lean on that client as possible, and you want that server, which OpenLDAP can scale. That's where you want the load. You don't want to put it on the client. So we thought it was a good idea. All right, so where does that leave us? Where is it? It's in our cellar. Okay. We haven't released the source code yet. We're still trying to figure out what we're going to do with it. The binaries are part of the Simus OpenLDAP installation packages. So if you want to try it out, you can do that. Talk to me. I'll point you in the right direction. The Java bindings are released. So it's definitely something that you could try out. But, you know, we're still trying to figure out what we're going to do with it. We think it's a good idea. I'm going around talking about it. Everybody seems to think it's a good idea, but we're not really sure what we're going to do with it. Okay, so that's it for this talk. I've got one coming up where I'm going to go into the bigger picture, which is Apache Fortress, which is my pet project. That's coming up. I think it's in Georgia A or B. And so if you can stand me for another 50 minutes, I'll throw some more Frisbees. And if you have any questions, contact me, join our mailing list, hit me up. I've got some phone screen cleaners. If you want one, come up, talk to me, I'll give you one. Or if you come to the next talk, maybe I'll hit you with a Frisbee. And so I think do we got time for questions? 5 minutes. Any questions?
Could you talk a bit to the multi-tenancy? So what's in scope of multi-tenant, what's not? So users, I imagine, would be sort of system-wide? No?
It's all multi-tenant. So I'm going to talk about multi-tenancy in my next talk. So some. But yeah, all the data is multi-tenant.
How do you handle access control? So like restricting what users can interact with the API itself?
I don't understand the question, Colm.
So how do you control who can call the API of the PDP? Like, and if they're authorized to call it, like, does that make sense?
Oh, so you're wanting to access control to even see if you can make the call? Exactly. That would be probably, you could do that with LDAP. Okay. So you could do that with ACLs, right?
Okay.
That would probably be the easiest way.
Any other question? Oh, I didn't see it. So XACML PDP is pretty configurable. How does this compare with that?
This would be I could see XACML as the wrapper for this, right? So, you know, one thing that I feel pretty strongly about is do what you're good at and let other people do what they're good at. So, and then you have a chance of maybe being useful to somebody rather than trying to be all things to all people. So we're really good at authorization. And so that's what we stay good at. And so if you know, you could see a scenario where an XACML could be using this as the system of record, right? And so that's how I see it anyway. But you would never do an XACML protocol to the LDAP server, right? I mean, that wouldn't make any sense at all. But the XACML policy decision point could then call this policy decision point. And with those latency times, it probably would be faster than anything else you'd be doing.
Yeah, thanks.
Yeah.
Another question?
How does the admin go from, you know, the picture you had with the various roles for your different types of users? How does an admin go from that scenario to actually getting this information into LDAP? Like, how does the admin edit the information in LDAP?
There's an administrative API. So Fortress has a set. Fortress, so back to the ANSI Insight specifications where you had the admin and the review and the system API. Do you remember that slide I showed? The admin is the administrative APIs. Apache Fortress implements the whole thing, right? So say you want to add a user role permission, you'd go through the Fortress APIs. Or you could do it via REST, via the Fortress REST interface, which uses Apache CXF, by the way. And then that calls the Fortress APIs. So it's just a wrapper, a REST wrapper. Thanks a lot, guys.